This is part one of the final exam notes page for Math 7-8. So you should have just one piece of paper torn out of your math notebook, and you're allowed to fill the front and back side of the paper. We're going to start by labeling this page, and we're going to call it Notes for Semester 1 Final. And then give it a little header, something that makes your title stand out. Let's start by looking at equivalent expressions, when we're dealing with negatives. So let's say you have something like trying to figure out what is also equal to some number A minus another number, which would be B. The numbers don't really matter. This is like just a general formula for how we would think about this. These could be any numbers here. So if we think about the different ways we can write this, this is equal to, one other way we could say is we could be adding negative B, because that's the same as subtracting B. We could also say that if we wanted to switch these around, now that it's addition, it could mean the same as negative B plus A. So because remember, there's a commutative property of addition, so if we've now identified that the B is negative and it's the same as adding a negative and a positive, we can flip it around and say that it could also be the same as this. For example, let's give it some numbers to make sense. If A is 5 and B is 3, negative 3. Well, 5 plus negative 3 equals 2. That's the same as negative 3 plus 5, right? Those would be the same answer. That would still be 2. Okay, so thinking about that, we're going to separate that. And we always want to use squigglies or lines to separate each example. We should also know that if we have a number and we subtract a negative number, that this means it's actually A plus B. So this is equal to A plus B. And we used counters before to show that. We also can use a number line. So if we put this on a number line, we're starting with A. I'm going to put A in the middle. And we're going to take away negative. Think about it this way. If we were adding a negative, we would go left. We were adding a negative like up here. We would go left like subtraction. But we're doing the opposite of adding a negative and we're subtracting it. So instead of going left, we're now going right. So we would add that B value. Okay, so let's do some problems with some values that are going to help us make more sense of this. You're going to have problems that's going to say, what is the difference between two numbers? Okay, so think about this. We want the difference between 125 and negative 23. So if you think about this also on a number line, negative 23 would be over here. 0 we could put, somewhere right here. And then 125 would be at the end. So you need 23 just to get to 0. Plus you're going to add 125. Also remember that difference means subtraction. So what we're saying is, what's the difference between 125 and negative 23? Meaning we're going to subtract negative 23 from 25. You have to use two symbols because difference means subtraction, and that negative 23 is its own number, its own term. So again, this is another example of why when we're subtracting a negative, we're actually adding a positive, because you need to go that distance first just to get to 0, then you add the positive amount to it. So you're really looking at this entire distance here. The difference between them is going to be 125 plus 23, which gives us 148. Okay, so there's another example. Now let's look at this if they were fractions. So if we have fractions, let's look at the difference between negative 1/2, the difference, subtraction, negative 1/2, and negative 4/5. Again, we should understand that this is actually meaning we're going to add these values. We could show that on a number line. We would put our negative 4/5 here and our negative 1/2 here, because negative 4/5 is, nope, it would be the other way. 4/5, no, 4/5 would go here because this is farther from 0. Confuse myself for a second. This is almost a whole, so that's farther from 0 than negative 1/2. And then you would be adding them. So if you have to choose the values that are also the same as this one, just like we did up here, you keep the first number the same, but you're really adding this. So it would be this one. Now, remember that once you have it as addition, there's another possibility that it could also, you could flip those around. This value would be the same as 4/5 minus 1/2. But I think I just want you to focus on this part for now. Okay, so I don't want to waste any space, so we'll just block this off right here and keep going. What if you have the distance? So now we're thinking distance in terms of context or on a number line. What's the distance? What are all the expressions that have a distance of 4.5? So you're looking for things that are 4.5 units apart from each other. I'm going to write down several things, and we're going to circle the ones that have this distance. So A could be negative 2 and 3.5. Okay, B could be negative 15 and 75 hundredths and negative 11 and 25 hundredths. C could be 15 halves and 7 halves. D could be negative 3 and 1.5. And I'm going to squeeze in 2 more, so we'll do E could be 6.2 and 1.7. And these could both be positive or negative. We'll leave them positive. Last one, negative 16 and 19 halves. So again, we want to pick the ones that have a distance of 4.5 units. If we're on a number line and we start at -2, we're going to 3.5. We have to get 2 units to 0 plus 3.5. That one's out. That's 5.5. We want 4.5. Negative 15.75 and negative 11.25. So they're still on the negative side. So we're just going from here to here. And this, when we subtract, it does give us 4.5. So this one would be a possible choice. See if there's any more. 15 halves is 7.5, and 7 halves is 3.5. Well, 7.5 minus 3.5 is only 4, so that one doesn't work. We start at -3 on the number line, and then we go to 1.5. That's 3 units to 0 plus 1.5, that's 4.5. If we start at 6.2 and we're looking to go to 1.7, we're going backwards on a number line. The distance, if we subtract, we would get, so think about it. You would have to borrow, right? So you'd have a 12 here. So you'd have, I'll do this to the side, 6.2 minus 1.7, we'd have to borrow, we would get 5, and 5 minus 1 is 4. So this one is a distance of 4.5 away. And then finally we have negative 16 and -19 halves is 9.5, and the difference between these would only be 6.5. Did I do that right? No, it would, this is a positive, so already you would need 16 units just to get to 0, plus this 9.5. It's going to be way more than a distance of 4.5, so that's out. This is going to be one of those select all questions, right? These type of questions. So you have to be careful and you have to check every single one. If you miss one of them and you only choose 2 correct ones out of 3, you get the entire problem wrong. And that really hurts your grade. So you want to make sure that on the select all ones especially, that you're picking all the proper correct answers. With that being said, that means that if you pick all 3 correct answers plus you pick another one that isn't, it still is going to mark it all wrong. So you can only choose the correct answers and you have to choose all of them. So we will mark this one off. Okay, I'm going to move back up to the top. What if we have a problem that says you want to know the product of, we'll say 3.2 and -4.6. So you're trying to find the product of those 2 numbers. Product tells us to multiply. So we need to multiply 3.2 times -4.6. You guys can work this out by hand, and then we'll apply the decimals at the end. And since we're multiplying a positive times a negative, this is where our integer rules come in, where if there's 1 negative, the answer is negative. If there's 2 negatives out of both of them, the answer is positive. So we'll work this out. We add them up. Oops, I almost put a 3. And then 2 numbers behind a decimal, our decimal goes there. This is a 4. Okay, it's negative 14.72 because we have our integer rules. So we'll mark these over here, that a positive times a negative equals a negative. This only works with multiplication and division. It does not work with addition and subtraction. This you have to make sense of with a number line. If it's a positive or a negative times a negative, it's a positive answer. And obviously if it's a positive times a positive, you know that's a positive answer. But let's just note here that it only works for multiplication and division. Okay, and maybe we need to put a little cloud around this one also, just to make it stand out more. So back to this up here, we can, we're going to just put equals and put our final answer, 14, negative 14 and 72 hundredths. Okay. This one's going to be super fun. All right. So let's say we've got a problem like this. Negative 3 times 1/8 times negative 1/5 times negative 6. So the main thing you need to do here, you've got to work 2 at a time. Only 2. Do not try and do all of them at once. You will confuse yourself and probably make a mistake. I've seen it happen many times. We're first going to multiply negative 3 times 1/8. This is the same. Negative 3 is the same as negative 3 over 1. Sometimes that is helpful, remember, because you can just focus on multiplying numerators, multiplying denominators. What I've seen a lot of kids do is they have this negative 3 and they multiply it times this and the bottom, and that's not right. This negative 3 as a fraction is negative 3 over 1. So negative 3 times 1 is negative 3, and 1 times 8 is 8. Now, we bring down the next one. We're going to multiply this answer times the next one, negative 1/5. That gives us, I'm going to move it this way, negative 3 times negative 1 is positive 3. 8 times 5 is 40. Now we're going to multiply times the negative 6. Remember, it's the same as negative 6 over 1. 3 times negative 6 is negative 18. 40 times 1 is 40. We need to reduce when possible. And I know it's possible because these are both even. So at minimum, I can divide both of these by 2. When I do that, I get negative, don't forget the negative, think about that first. 18 divided by 2 is 9, and 40 divided by 2 is 20. So that's the final answer, negative 9/20. I'll block this example off. We're going to do a couple more for today, and that'll be the end of the part 1 video. So let's move over here. You're going to want to, how do I want to do this? We'll put it in here. If you want to find the square root of a fraction, it's the same way you'd find the square root of a whole number. For instance, square root of 16 is 4, right? Square root of something like 25 169ths, you're trying to figure out what number was multiplied times itself to get 25, that's 5. What number was multiplied times itself to get 169? 13. So this equals, remember when you're finding the square root, you don't put it in your answer. It's just the fraction 5/13. And I don't know, you guys can use highlighters and things if there's certain things like this one where you're like, oh yeah, that was a long time ago, and highlight it to make it stand out more so it doesn't get lost in all your work. Okay, one more. This is a word problem. We're going to go ahead and spell it and write it out. So if you paid $5 for nope, $6. Sorry, my bad. I changed it. If you paid $6 for 3/4 pound of hamburger, what is the price per pound? What is the price per pound? So this is unit rate, right? We're trying to figure out if it was this much for 3/4 of a pound. This is where I taught you guys to set up what are called like algebraic proportions. So let's review that. So it's $6. Remember, $6 is the top number. It's always the output, the Y value, the cost. For 3/4, that goes on the bottom. We want to know how much it is for 1 whole pound. Pounds is bottom, cost is top. We don't know the cost, so we put an X. And I hope you remember at this time, that means that we cross multiply. So I'm just going to show that maybe with this pen. Should have put an equal sign here because they are equal to each other. We're going to cross multiply and solve for X. So we get X times 3/4 is 3/4 X. 6 times, and that equals 6 times 1 is 6. So make sense of that. 3/4 of a pound, right, is $6. To undo this fraction, because it's being multiplied by X, we have to divide by it. But when we divide by a fraction, we multiply by the reciprocal. So I'm going to write that down. Multiply by the reciprocal. Now, many of you have learned that as keep, change, flip, or KFC. You memorized that acronym, but you don't. But this is the mathematical reasoning behind it. If we multiply by 4/3, it looks like this on both sides. These equal 1, so you're left with X, just X, 1X. And I'm going to explain that because 4 times 3 is 12 and 3 times 4 is 12. Well, 12 over 12 equals 1, okay? Now you do this side. Remember that 6 has a denominator of 1. So you multiply numerators. 6 times 4 is 24. And 1 times 3, the 1 underneath the 6, 1 times 3 is 3. Well, 24 divided by 3 equals 8. So it costs $8 per pound. Okay, so that's the last one we're going to do for part 1. Your notes page, I'll kind of zoom out a little bit. I filled almost my entire front page up Hopefully you didn't go past one full page because you still want to leave some space to fill out the back side. And I wanted you to leave a little bit of room to add other things that you feel are important as we continue to work through stuff. And maybe, you know, there are things that you still think you need extra practice on or you want to be able to reference on here. And so you want to leave a little extra space. So in the next, we'll do one more notes video. And just make sure you write smaller if you're finding that you're running out of space too quickly. Okay, if you need to redo it to fit it all on the front page because you went over already, you might want to consider doing that so you can fit more, because you can only have the one page of your notes. All right, so I'll talk to you guys again in part 2.